Great hosts, welcome you back to inverse functions. Today we are looking at the second lesson where we are going through the inverse of an exponential function. Alright, we are not going to take the general form as you did it in grade 11, but we are only going to focus on the form y is equal to a to the power x, where a is greater than 0 and a is not equal to 1. Now the inverse function of an exponential function requires the knowledge of logarithms, which is a new concept that you need to learn. So here I have some examples which will assist us to understand how to convert the exponential form to logarithmic form. Okay, we know that 100 is equal to 10 to the power 2. We can write this in exponential form in this way. We are saying the logarithm of 100 to base 10 is equal to 2. So we can shorten that to log 100 base 10 is equal to 2. 32 is equal to 2 to the power 5. We can write this as log 32 base 2 is equal to 5. B is equal to c to the power 5. We can write this as log b base c is equal to 5. Y is equal to a to the power x. We can write this as log y base a is equal to x. So you can see that the logarithm of a number to a given base is simply the power to which the base is raised to give the number. So in other words, we can say the logarithm is an exponent. Now this knowledge we need it to assist us when making y the subject in the process of finding the inverse function of an exponential function. Let's look at the example that I am having here. We are given that y is equal to f of x, which is equal to the power x. Alright, as usual, we take y is equal to the power x, we write it down. The first step is to interchange x and y. So we have now x is equal to 2 to the power y. Now there comes the problem. How do we make y the subject when it is a power? So this is where now we need to use logarithms. We have said the logarithm of a number to a given base is equal to the exponent, which is that power. So we are saying the logarithm of x to base 2 is equal to y. So it means that y is equal to log x base 2. So now y is our subject, which implies that the inverse of f of x is simply equal to log x base 2. So that is how we find the inverse of the exponential function. Now let's look at this graphically. Still, the concept still stands that the two graphs are a reflection of one another through the line y is equal to x. So this is our f of x. We have already seen that f of x is an increasing function. It cuts the x-axis at the y-axis at 1, and then it has another point 2, 4. You can have another point on this side for you to get the shape of the graph, but the asymptote is the line y is equal to 0, which is the x-axis. That means this changes. The asymptote now becomes x is equal to 0 for the inverse, which is the y-axis. That is why the graph is like this. Alright, so everything else is the same as the linear function, the reasoning. There is no much difference there. So I want you to go through this activity. After going through this activity, then you compare with what I will have given you. You may stop the video and then work through the questions, and then you continue with the video. Alright, so let's look at question 1. Question 1, we are given that g of x is equal to 3 to the power x. We are being asked to find the inverse of g of x. So that is quite simple. G of x is the same as y is equal to 3 to the power x. We interchange, that is x is equal to 3 to the power y, and then we use logarithms, that is y is equal to log x base 3. Therefore, the inverse of g of x is equal to log x base 3. That is part A of the question. Now part B of the question, they are saying write down the values of x for which log x base 3 is greater than 0 but less than 1. Now, the correct interpretation of this question, it needs you to look at the graphs of the two functions. Let's just sketch the graphs here. Alright, for the graph of y is equal to 3 to the power x, we understand that it casts the y-axis at 1, and the shape of the graph is like this. And then the inverse, obviously, it will cut the x-axis at 1. And these two graphs are a reflection of one another along the line y is equal to x. So log x base 3 is the inverse function, and log x base 3 is the same as y is equal to log x base 3. So in other words, we are saying y for which values of x is y greater than 0 but less than 1. So let's go to the y-axis. 0 is here, and then 1 is here. Then let's go to the graph and find the values of x. So here it's 1. Let's go to the graph and find the value of x. Alright, so when y is 1, our x will be 3. If you do your substitution, when y is 1, we'll be saying 3 to the power 1 is equal to x, that is x is equal to 3. So that means log x base 3 is greater than 0 but less than 1 for the values which are between 1 and 3. So our solution will be x is greater than 1 but less than 3. Let's go on to the second question. The second question, we are given that g of x is equal to log x base 2. Determine the equation of the inverse of g in the form y is equal to. So on number 2, g of x is equal to log x base 2. So this, we write it as y is equal to log x base 2. Now the first thing is to always interchange. So we are saying x is equal to log y base 2. Then we now move from the logarithmic form to the exponential form for us to make y the subject. So remember, is the number, which is y, is equal to the base raised to the exponent, which is x. So y is equal to 2 to the power x. So in this way, y is the base. Alright, so we are saying therefore, that is the form which the question wants us to leave the answer in. So we are done with the inverse of g of x. Now you need to be very careful when you apply logarithms. Apply logarithms after you have interchanged x and y. That way you get your answer very correct. I hope everything is in order. We meet again in lesson 3. Bye bye.